Hello viewers, this is lecture number 1 of transportation and game theory. In this lecture we are going to cover transportation problem, feasible solution, basic feasible solution, degenerate basic feasible solution, optimal or optimum solution, balanced and unbalanced transportation problem, and then we discuss northwest corner method. So we start with transportation problem. The transportation model is a special class of linear programs that deals with shipping a commodity from a source. Source means factory. To destination. Destination means warehouses. Our objective is to minimize the total shipping cost while satisfying all the supply and demand limits. Okay. How we can think about this? This is our source. These are supply points. Or we can say sources. And this is destination. We have sources A1, A2, A3, and so on, AN, AM. We have destination B1, B2, B3, and Bn. So A1, A2, A3, these are units of supply. These are units of supply, and B1, B2, B3, Bn, they are units of demands. Cij, if we have here Ai and Bj, Bj is the destination point. So Xij is quantity transported from ith source to jth destination, from I to j. So if we send some supply from Ai to Bj, so supply is Xij. Cij is unit cost of item transported from I to j per unit cost. So if we send Xij item from Ai to Bj, then Cij is the cost of per unit item. Similarly, if we send some item from A1 to B1, then X11 means number of quantity transported from first source to first destination, and the cost associated with A1 to B1 is C11. Similarly, if we send some item from A1 to B2, then X12 is the quantity transported from 1 to 2, and C12 is the cost associated cost of per unit item from A1 to B2. Similarly, we can A1 to B3, X13 number of item, C13 is the cost associated, and from A1 to Bn, X1n is the number of item, number of quantity transported from I to J, and C1n is the cost of 1 unit. Similarly, we can send A21, A22. A22 means we send A2 to B2, A2 to B1. So we can draw with another color. So this is A21, this is A22, item X22, cost associated is C22, this is A23, and similarly we can send item from A2 to Bn, X2n, and cost is C2n. And then we similarly we send A1 to B1, that is C AM to B1, that is XM1, and cost is CM1. And similarly to AM to BN, number of item XMN, and cost is CMN. So we can send items Xij from supply point to demand point with cost associated with each item is Cij. So what is the purpose of transportation problem? Our objective function is to minimize the transportation cost. Minimize the transportation cost. That is, we have to minimize summation I equal to 1 to m, summation j equal to 1 to n, Xij, Cij, or we can write Cij into Xij. Now the constraints are summation Xij, this must be less than equal to ai for all I. Summation Xij must be greater than equal to bj for all j, and Xij quantity transported from ith source to jth destination must be non-negative, that Xij is greater than equal to 0. Summation ai, if we have these a1, a2, a3, a4, an, these are units of supply. So if we add all these, then summation ai, I equal to 1 to m. This is total availability. Summation bj, j is equal to 1 to n. This is total demand. So if summation ai I equal to 1 to m ai is equal to summation j is equal to 1 to n bj, then the problem is, then the transportation problem is balance problem. And the transportation problem is balance problem. If summation I equal to 1 to m ai is greater than equal to summation j equal to 1 to n bj, that is if total availability is more than or equal to the total demand, then the requirement is met. Then the requirement is met. We are able to fulfill the requirement. When? Because total availability is greater than or equal to total demand. If total availability I is equal to 1 to m ai is less than j equal to 1 to n bj, if total availability is less than total demand, then the requirement is not met. Then requirement is not met. We are not able to fulfill the requirement. So we basically deal with the balance problem. If the problem is unbalanced, we try to first make the problem to be balanced. So balance problem has equation. And unbalanced problem has inequalities. So if we have unbalanced problem, it means either supply is more than demand or demand is more than supply. So we have two types of transportation problems. First is balanced transportation problem. Other is unbalanced transportation problem. So before discussing balanced and unbalanced problem, we first define some definition. First definition is feasible solution, a set of non-negative individual allocations, that is Xij, which simultaneously satisfies all the demand and supply constraint, is called feasible solution. Basic feasible solution, BFS, be denoted by BFS, a feasible solution to M origin and N destination. We take M origin A1, A2, AM and N destination B1, B2, Bn. So a feasible solution to M origin and N destination problem is said to be the basic if the number of positive allocations are M plus N minus 1. M plus N minus 1 means that is 1 less than the sum of rows and column of cost matrix. M is number of rows, N is number of columns. So if the number of sum of rows and column is less than 1, that is if number of allocations are M plus N minus 1, then the solution is basic feasible solution. In non-degenerated basic feasible solution, definition third is degenerated basic feasible solution. If number of allocations in a basic feasible solution, number of allocation means we have M plus N minus 1 number of allocations or for basic feasible solution. If number of allocation in basic feasible solution are less than M plus N minus 1, अगर उससे भी कम आ रही है, M plus N minus 1 से भी कम है, then it is called degenerated basic feasible solution. Otherwise, if it is equal to M plus N minus 1, then it is non-degenerated basic feasible solution. That is, in non-degenerated basic feasible solution, the number of positive allocations is exactly equal to M plus N minus 1, and these allocations are independent in independent position. Independent position means if we move allocations by straight lines, if we move by straight lines, then if we start from this point, then we are not able to reach at the same point by using straight line. So if we are not able to reach the initial point, then the allocations are independent. If we reach to the same point by using straight line horizontally or vertically, then the allocations are not independent. So we must ensure that all the allocations are independent. Definition 4 is optimal or optimum solution. A feasible solution, not necessarily basic, is said to be optimal if it minimizes the total transportation cost. If we get the minimum transportation cost, then the solution is optimal. And next is balance. We have already discussed about balanced transportation problem. The transportation problem is said to be balanced if sum of supply and sum of demand, that is total supply equal to total demand. That is summation AI is equal to summation Bj. I equal to 1 to M, J equal to 1 to M. Unbalanced transportation problem. If the total demand is less than the total supply, that is summation Bj, demand is less than total supply, summation Bj is less than summation AI. Or if total supply is less than total demand, then it will be unbalanced problem. So we can say that if sum of supply is not equal to sum of demand, the total supply is not equal to total demand, then the problem is unbalanced. Summation I equal to 1 to M AI is not equal to summation J equal to 1 to N Bj. So we identify basic feasible solution by 3 methods. So we identify basic feasible solution by 3 methods. First is northwest corner method. Northwest corner method, NWCM. Second is minimum cost method. Minimum cost method, or we can say least cost method. Least cost method. Third is Vogel's approximation method. So today we are discussing only the problems related to northwest corner method. So example, solve the following problem by northwest corner method. So this is the transportation problem. 13, 15, 16, these are the supply points A, B, C. These are the destination. Let it be 1, 2, and 3. We have 3 supply point and 3 destination point. So we have to apply the northwest corner rule. So we take care the direction, how we can use northwest corner. So this, by direction we know that northwest is in this direction. So we follow northwest rule, northwest corner, and we use. So in this table we can see that this A1, this is A source and first destination. So we can call this A1. This is the northwest corner for this table. So we supply is 17 and demand is 14. तो हम क्या करेंगे, what we do, हम यहाँ 14 allocation 14 item allocate कर देंगे. So we allocate 14 items. अगर यहाँ 14 item allocate की, then this demand is fulfilled. So we cancel out this. और यहाँ से 17 item में से 14 हमने supply की हैं. So we have left with 3 items. Now we have only these 6 columns, 6 boxes. These are non-allocated positions. So now northwest corner is this corner. Now we allocate, we have only 3 items. So we allocate only 3 items in this place. If we allocate 3 items, then supply from this source is cancel out, and we have fulfilled only 3 items to second destination point. Second destination में कितनी item बच गई अब? We have to supply 5 more items. Okay. Now we have 4 non-allocated positions. Supply कितनी है? 12 की है. और यहाँ demand कितनी है? 5. So we put only 5. अगर 5 यहाँ से cancel हो गया, it means this we cannot put any we cannot mark any allocation in these position. So 12 minus 5, we get only 7 at this point. So now we have only, we encircle all the allocated positions. Okay. Now we have only 2 non-allocated positions. So we have only one option. We first supply 7 items to this. So 23 minus 7, we have 16 left. So 7 cancel out. Now we have 16 items. We send 16 items to this and this. Now all the allocations, all the supply and demand. Yes, first point is, before discussing this problem, first we have to check whether it is balanced or not. So 17 plus 12, 19, 19 plus 16, it is 35. 14 plus 8, sorry, 17 plus 12, 29, 29 plus 16, that is 45. 14 plus 8 is 12, 12 plus 23 is 45. So sum 45 supply, total supply and total demand both are equal. So it is a balanced problem. So first we have to check this, then we allocate the position. Okay. Now number of rows, source are, we have M is equal to 3 sources. Destination, we have N equal to 3 destination point. So what we do, we have to check whether it is a basic feasible solution or not. So what we do, for basic feasible solution, the number of allocations are M plus N minus 1. So 3 plus 3 minus 1. So we must have 5 3 plus 3, 6 minus 1 is 5. So we can check that 1, 2, 3, 4, 5. So 5, we have 5 allocated position. So this is a basic feasible solution. Now the transportation cost is, transportation cost is 13. 13 means per unit item. हमने कितनी आइटम यहाँ सप्लाई की? We have sent 14 आइटम, और एक आइटम का कॉस्ट कितना है? 13 रुपीज. तो 14 का कितना हो जाएगा? So we have transportation cost transportation cost is equal to 13 into 14 plus 15 into 3 plus 11 into 5 plus 2 into 7 plus 9 into 16. So it is 182 plus 45 plus 55 plus 14 plus 144 and 182 plus 45 plus 55, it is 100. So 282 plus 158, it is 440. So transportation cost is rupees 440. So in this way we can solve northwest corner method. Let us discuss another example. Solve the following transportation problem by northwest corner method. A, B, C, these are source plants where some manufacturing happening. 1, 2, 3 are warehouses where we have to send items. Supply A source में 20 items, B 28, C 17, demand 21, 25 and 19. The sum of supply and demand 65, so it is a balanced problem. Now these are 7, 6, 9, 5, 7, 3, 4, 5, 8. These are the costs associated to from ith source to jth destination. Okay, so we first start from this position because this is the northwest corner. So 20 item, we have supply of 20 item, demand is 21, so we can put 20 item here. If so, this supply is complete, we have left with only one item. Okay, now we have these 6 non-allocated position. So northwest corner is this, so we send only one item. Okay, then the demand is fulfilled, so we have left with 27 items from B A2 source. Now these are 4 non-allocated positions. 27 is a supply point, this is the northwest corner, 25 is the demand, so we sent 25 items there. So we left with 2 items, and this because it is fulfilled, so we cancel out this. Now we left with only 2 positions, so this cancel out, we left with 17 item, और उसके बाद हम 17 यहाँ पर send करेंगे. Then all the supply and demand constraints are satisfied. Now the number of allocations are 1, 2, 3, 4, 5. Okay, so here M is equal to 3, N is equal to 3. So number of allocations are 5, 1, 2, 3, 4, 5. So we satisfied M plus N minus 1, that is equal to 3 plus 3 minus 1, that is equal to 5. So this we found the solution is initial basic feasible solution is found. Now what we have to do? We have to find the transportation cost. Now the transportation cost. Transportation cost is 20 multiplied by 7 plus 5 multiplied by 1 plus 25 into 7 plus 3 into 2 plus 17 into 8. So when we add When we add these, you can multiply this, you get rupees 462. So the transportation cost is rupees 462. Now, next example is, you can try this one. Supply is given, demand is given. So we quickly solve this example. We have 40 items. This is the northwest corner. We can send 20 items here. This is fulfilled. So we cancel out this. We left with 20 items from source one. Now the next northwest corner is this one. यहाँ पर हम कितनी 20 आइटम, we have only 20 items, so we can send 20 items. So we can cancel out. So 10 items left in demand at station B2. Now this is the northwest corner. We can send only 10 items. So this demand is fulfilled and supply remain 50. This is northwest. 50 item supply point में 50 ही demand है. So we can send all the 50 items. So this fulfilled. Now we have left with only 50 items. So now the supply and demand constraints are satisfied. So now we can check number of source m is equal to 3. Number of destination n is equal to 4. So number of, for basic feasible solution, we have m plus n minus 1 allocations, but we have only 4 plus 3 minus 1. We have 6. We need 6 allocations, but we have only 1, 2, 3, 4, 5. So what we do for basic feasible solution, what we do, we can put any allocation by adding 0. We can mark any allocation by adding 0, but make sure that it does not become a loop. So we can put 0 here, or we can put 0 here. You can put anywhere. Either you put 0 in 8 position, this position, or you can put 0 here. This will not affect, but it satisfies the condition m plus n minus 1. Now the transportation cost is TC, that is equal to 20 into 4, that is 80, plus 20 into 6, that is 120, plus 10 into 8, that is 80, plus 50 into 6, that is 300, plus 50 into 8, that is 400, plus 0 into 5, that is 0. So we get 400 plus 300, 700, 700 plus 120 plus 80, 200, 900. So cost is 980. So we have discussed about northwest corner method in this lecture. So I hope you will understand about how we can solve the problem related to northwest corner method. In next lecture, we will discuss about least cost method and Vogel's approximation method. Thank you.